Morning guys, welcome back to the channel. I'm in bright and early this morning. As you can see, it's 6:30. I've been in for about an hour. I've had a good old sort out here. The L200, I've just popped back to sort of a basic engine really. That one's got to go back. As I said in the previous video there, we haven't got that job unfortunately. What I've done, as you see, we've got a big space here now. I've moved the 200SX engine off this bench here and put it all over there because we're still waiting for a clutch and flywheel on that to get the crank assembly finished balanced. I've put the jag here, all the jag bits. So I think we got the headset yesterday. So all the jag is sort of ready to go back together. This Cosworth here is the one with the broken camshaft. What I'm going to do this morning is start to pull this one apart and see what we've got. I've took out all the hydraulics, but as you can see, all these valves here are a lot lower, so obviously they're all going to be bent. I'm just hoping it hasn't broke the heads off any of the valves and damaged the block good and proper. But he wants to go all out on this one, so we're probably going to stick the ductile iron liners in it. We're going to get probably a T38 or something like that. This one here is going to be about 450 horsepower because it's going in a Mark 1 Escort. So that's going to be plenty fruity enough. So yeah, let's get all the ancillaries off this, pull the cylinder head off and see what we've got inside. Cylinder head is off the Cosworth now. I've just dragged the block outside before I go stripping any more bits off it. As you can see, it's a bit caked in grease and oil, so rather than get all my tools filthy, I'm just going to blast it and get it to a point where I can sort of see all the nuts and bolts. But on first inspection, the valves are bent on that one side, as we thought they would be. As you can see, all the marks, it looks like all the valves have hit the pistons at some stage. And I'm assuming the big old dings in this side here are the inlet valves, which has happened when the belt slipped. So yeah, we haven't stripped the head yet, although the exhausts do look all bent. The inlets maybe as well if they've all touched. So we shall get those springs off and get the valves out, spin them up and see if we've got, see how many bent ones we've got. But yeah, on first inspection, the block face actually, can't really see any signs of any cracks in that in the usual places, which is a good thing. It means the block's not scrap. There's a big old wear ridge under there, but that's as to be expected. I don't know whether it's been bored yet. I haven't measured it, but yeah, let's get this cleaned off and then we'll get the sump off and see what we've got inside. Right, so we've got the sump off the Cosy. The sump looked pretty disgusting inside. I've given this a pressure wash now, but as you can see by the colour of the base of the block and all the rods on the crank and the oil pump and pickup, that does not spell well serviced to me. Whether it's, you know, but bearing in mind this is a two-wheel drive engine, so it could be fairly old. I haven't checked the bearings yet, so I'm not sure whether they're standard, but this thing could have been, you know, never been took apart. But yeah, it certainly looks a bit grotty, so we'll just get all the rods out, check all the bearings, check the crank and see what we've got there. Sorry it's a bit noisy. John's just out there pressure washing the Healey block. We've had the pistons today. They've turned up, so he's finished boring it. I'll just show you a piston quickly. This is the new piston at plus 60, so he's just checked the clearance and that's all good. So just quickly, I'll show you inside the Cosworth. Now we've got the crank out. You can see they're all standard original Ford bearings, but as you can see, it's the usual down to the copper back in. So you can see on the big ends and the mains, that's gone through the white metal to the copper. So the crank is definitely going to need a grind, although it's not that bad. I'll show you it here, look. But as you can see, not too many more miles and that would have started to wreck the crank. So we've caught it just in time. So I'm just going to get the pistons out of this now, take the pistons off the rods, get those rods cleaned up and start getting some bits on order. Right guys, slightly off the subject of the Cosworth for a moment. I think this is very important that I put this in the video. John is building the Healey 3000 engine. He's got the crankshaft in, all good. Got the rods, the pistons on the rods, and he wants to just get the pistons and the rods down the holes for today. First of all, this is a prime example of why we do not take anything for granted. It doesn't matter how good a quality the parts are, it doesn't matter where they come from, we check every dimension. We size everything, so it's really what you're doing is you're blueprinting every engine, really. And as I say, this is a prime example of why we do that and why it is very important, because you've got to bear in mind we build engines day in, day out, we do tons of different stuff and we sort of know the ins and outs, so it's bad enough for us really. But for you guys at home that are maybe building your own engine, you may even have a bit of an engineering background and not really too familiar with building engines. We just want to try and educate you through these videos on what to look out for, because it is very important. So what we've got here is one of the pistons on one of the old rods for the Healey 3000. Now these pistons, when they turn up, or when they turned up, I'm not going to mention any manufacturers' names or suppliers or anything like that. I'm not out to, I know a lot of you guys will comment saying name and shame, but not going to do that. This is purely for an educational, on an educational basis for you guys, really. So the quality of these pistons look fantastic. Now, before we put a piston in the hole, obviously first of all, when we get the pistons, we always measure the skirts on every piston and make sure the running clearance is going to be what they suggest. So as I've said to you before, usually the bore size will be the round figure. So whatever size, say if it's 86mm for example, you would bore it to 86mm. Depending what it is, we will give it, if it's competition, we'll normally give it sort of half a thou extra on top of that. But a lot of the time, and especially on the classic car parts market, we've had it before where it's supposed to be a a bore to the round figure, so say 86, and the skirt of the piston should measure less what the running clearance is. So that would measure about 3 thou. If it's a 3 thou running clearance, it'd be 3 thou off the 86mm. I know I'm doing imperial and metric again, but that's just the way I work. Or 0.075 of a mil. But anyway, so that's the first thing we do. We check that the running clearance is going to be right. Then what we do is put the rings on, obviously in the right order, making sure if there's any markings on the rings, if it doesn't say top and it's just a mark, that mark will be facing upwards. Okay, so that is very important. We make sure that the rings are in the right order, so you've got the top ring where it should be at the top, the oil control ring where it should be at the bottom, and then the middle ring. As you can see on this piston, there is 5 rings, so you've got basically an oil scraper, an oil control ring, 2 oil control rings, one down the bottom. You've got 2 different designs. You've got a solid oil control ring down here. You've got the expander there with the 2 rails, so they are separate. It's a 3-piece oil control ring. Then you've got your 2 center rings and usually your compression ring, but these are all the same on this. So you've got 3 compression rings basically at the top. So the problem that we've got, so John's obviously put the ring clamp on here, and what he's done is put the rings on, pulled them back into the grooves and just made sure that they're all below the grooves. He's put the ring clamp on, pushed the piston down the hole, gone in past the first ring, because obviously you're going from the top, gone past the first ring fine, got to this oil control ring, gone very tight. When I say very tight, I mean very tight. So he's obviously took it back out, and at the top of the bore, probably how far it's gone in is about 3mm, I'd say. It's gone a bit dark where you can clearly see it struggling to go down the bore. So he's took the rings off, he's had a good look, he's got in a right tiz with it, bless him. What the problem is where the 2 rails sit against the expander, the width of the rail and the back of the expander measure 185 thou. The depth of the groove is 175 thou. So these rings are sticking out either side, well, overall 10 thou, so either side 5 thou, and that is when they're fully compressed against the back of the groove in the piston. For any of you guys that don't really know what it should feel like, you would probably assume that, well, it's got 5 rings on, it's going to be a bit tight, because they are a bit tighter than the modern pistons with the 3 rings. But your all control ring is sticking out of the piston about a thou more than it should do on either side. So it's constant pressure against the bore. It's either going to wear the all control rings excessively to start with, or it's going to wear the bore. It might seem very simple, guys. It is a manufacturing error. You can only imagine this is one little bit of the engine, but you imagine everything that you fit in, as in new bits. It's the thickness of the shells, the width of the shells, the thickness of the thrusts. Although it seems very little, the pistons don't go down the hole. So yeah, as I say, guys, it was just a little sort of lesson really on what to look out for and the things to look out for, and also the reason we do things the way we do, because exactly this really. So the moral of the story is, guys, check everything, double check everything, don't assume anything is going to be right, and just be very careful. Right, guys, as you can see, the Cosworth block has all been bored. It's, to be honest, with the big sort of lip up the top there, the wear, it's only just cleaned at 0.5 mil on a couple of them. But just set it up to reface the block, and as you can see, I've given it a sort of 3 thou cut as I normally do first off, and you can see where it hasn't cleaned and where it has cleaned. So the usual on these Cossies, you can see where it's pulled up around the bolt holes. So that is the usual on these, especially the old 205 blocks. You can see where it's sort of touched on this one edge and round here, but where it's missed is where the gasket's blowing, and you can see definitely on number 1 where the gasket was blowing good and proper here anyway. So this block was long overdue for a recon really. But yeah, just thought I'd show you that, because that is a classic first cut finish on a Cossie block. The only trouble is with these, as I say, you can't long stud them, so the customer is fully aware that, you know, because you can't long stud them, if he tunes it, the 205 block really, as far as this can, you know, these bolt holes are concerned, where they crack into the water jacket, it's a time bomb. It could happen tomorrow, could never happen at all. So he's fully aware of that. So we're just going to give this another 3 thou cut and see what it cleans like. Here we go, Cossie block back on the stand. So we finished honing it, faced it. It did clean up after that 3 thou. So that's 6 thou we've took off the block face, assuming that this was original. Basically we have to do a dummy build anyway and get our piston protrusion correct. But yeah, so the block is pretty much finished. I'm just going to take these core plugs out now and give it a thorough clean. It's strange, this one, because every now and again, usually these old Ford blocks, whether it be a Crossflow, Pinto, Cosworth, whatever, they're a really nice cast iron, and they hone absolutely lovely and machine, you know, really nice. They're almost like soft, but every now and again, whether it's to do with it being sort of work hardened, but I get one that is a bit of a bugger to hone, as in it seems really tough. It hones a little bit like the ductile iron liners hone. So, and this was one of them. So whether it's to do with sort of work hardening over time, not quite sure on that. Maybe some of you guys can sort of comment down below and tell me sort of whether you're more familiar with the materials. But yeah, definitely this one was a bit more tougher than the others. But anyway, it's all to size, all done now, thorough clean, and that one I've actually managed to clean most of the bits. All the bits are on order. We've sent the turbo away. That's gone today. So Vince is going to do his magic at Turbo Performance, building us a T38 using the existing rear housing of the T3. So yeah, looking forward to getting that back. Got the pistons today. Just got to do our piston pockets and machine the top, and it's all ready to put back together, hopefully. Well, thanks ever so much for watching, guys. If you haven't already, hit the subscribe button, hit the notification bell, comment down below, and we'll see you in another one. Cheers, guys.